Wireless Communications Alliance presents free webinar. Wireless Power Transfer. Now and the Future is on Thursday, March 25th between 4 and 5:30 p.m. Pacific Standard Time. Location: Zoom video conference. Wireless power transfer technology has been a fascinating topic for decades. It was mainly a science project for more than 50 years, and only until the last 10 years the industry started to take a significant investment to develop this technology into commercial and consumer space. Why? Because the number of electronic devices has reached a critical mass and require more flexibility than the wiring solution. In this WCA event, we will present a few compelling applications that require wireless power technology and understand what's the current challenge and where we are heading in the future. Among those applications include EV, consumer electronics and IoT. We are pleased to invite industry leaders in their respective field to talk about their work.
Okay, countdown is running. Okay, everybody. Peter Walter here. I'm the president of Wireless Communication Alliance. Be greeted and welcome to one of our events about wireless power transfer with the subtopic today, now and the future. So I said, Peter Walter, my name, president. If you want to contact us, best is using my email address, peter.walter@wca. If you want to have more information what we are doing, go to wca.org. From 100 feet above, this is what we are doing since 1994. So the Wireless Communication Alliance is a non-profit business league dedicated to collaboration in the wireless industry. In the past, it was Silicon Valley, and now the only benefit what pandemic brought and Zoom is we can reach worldwide. A big thank you to our sponsors and partners who make this possible since 1994, inclusive but not limited to Asbill, Google, and CIG. Thank you again to our big sponsors. Here I just got asked what is the focus and the schedule for our next upcoming events. So we try in April an event about broadband for underserved rural areas. We have invited Marty Cooper and will perform a virtual book signing event. In May, we have a huge event together with Telecom Infra Project, TIP. You may know this Facebook organization about open Wi-Fi. We try to have something in June also about IoT applications, private equity and hedge funds. Are probably applications of IoT. Like I said before, in September, we have Oktoberfest dedicated to IoT, gizmos, and gadgets. And then we have our flagship event in November, our annual What's Hot event, where venture capitalist and M&A gremium will talk about what was great in 2021 what is not so great in 2021, and also the focus what will come in 2022. With this, a little bit housekeeping. So the Zoom chat, please use the Zoom chat section for the question. Presentation and recordings will be available within 48 hours on our website and also on our YouTube site. And again, greetings to the world and thank you for being our guests. So we have guests from Singapore, Japan, Europe, and of course, United States East Coast. Last but not least, we will have a raffle today. In about 85 minutes, you will see me again with a raffle. So we will raffle off one of these wireless floating power desk lamps. The winner has to be present in 85 minutes when the raffle is done. So with this, I hand over to Jeff Yen and his panel. Jeff Yen, moderator, is the CEO of Etherdyne Technology. You see the emails also where you can reach them. And he is also on the board of WCA. One of the panelists is Simon Mcgellar from Dinesh from Wireless and Wireless Technology. Then we have Ashish Mehta from TransferFi in Singapore. And we have Tom Okada from Vitricity. With this, Jeff, I stop my sharing and hand over to you.
All right. Thank you, Peter. So hi, everyone. Welcome to this wireless power event. So we actually dedicate this event to talk about wireless charging and wireless power. Traditionally, WCA is doing all the wireless communication, but now we are integrating the communication with the power, which is actually a fascinating subject. As everybody knows, since from Tesla's time back in 1900, this is a part of his dreams. And I think now these days, more and more devices are on the market, more and more battery and more wire. So there are multiple, industry players actually start, solving the, basically the last mile holy grail of the wireless power. So, so today we have 4 speakers, and they are all from their respective industry, and I will welcome them and thank you for their time, and thank you all the people for your time to join this. So hopefully you will find this event helpful and useful. So without going any further, I would like to start introducing our first speaker, Dinash Kitani. So Dinash Kitani is the founder and the chief analyst at Wired and Wireless Technologies, a strategic technology analyst and a consulting firm focusing on wireless power supplies, and the emerging EV, electric vehicle charging infrastructure market. So Dinesh, the floor is all yours.
Perfect. Thank you very much, Jeff, and good morning, good evening, and good afternoon, everyone. This is Dinash Kitani here, as Jeff mentioned. Let me first start sharing my screen, and please confirm, Jeff, if you can see my screen.
Yes.
Perfect. And is that a full screen now?
Yes. Well,
Perfect.
I think it's your presenter view, actually.
Sorry?
It is it's a presenter view, not a full screen.
Perfect. Just let me shift the screen, yeah. How about now?
Yep.
Perfect. Yeah, again, thank you very much, first of all, Peter, Tom, Jeff, and the team at WCA for giving me this opportunity to present the overview on the wireless power market. And as Jeff mentioned, my name is Dinash Kitani. I'm the chief analyst in Wired and Wireless Technology, a technology analyst firm, and focusing more on wireless power and power supply market. Okay, perfect. Basically, I'll be covering very overview on the wireless power market, basically what's the wireless power technology landscape, look into how the applications are rolling out wireless power with regards to the various technology we adopted, and more about the how big is the market opportunity here. Very briefly, just a slide or two on the company here. My company, like I said, is called Wired and Wireless Technology, a strategic technology analyst firm, consultancy firm as well. We basically deliver research, insights, and strategies Basically, the company is founded and supported by our believers, which is our clients here. And it's backed by a thorough research and analysis practices that we follow. A subject matter expert, including myself, operate as a trusted advisor and a strategic business partner to our clients. Again, our core expertise for the business is wireless power technology, power supply, and EV charging infrastructure market. Our subject matter experts have extensive experience and knowledge on the wireless power market, and they're well networked in the industry. Again, the vision is to be the most trustworthy and a sought after market research or analysis firm in the industry that we excel into. I would recommend that you please visit our company website and also follow the page on the LinkedIn so that you get the latest insights, trends on the wireless power market. Broadly on the coverage on wireless power market, again, this is a very important slide, not only to promote the products that we have, but also to let you know that the reason for our coverage of these applications, which are more than 30 plus, is not that because we just want to cover them. This is the applications where we have already seen some traction in the market. There's only a lot of R&D work, a lot of development work. And in some of them, we have seen applications or shipments already being happening. And if you see here, there's wireless power across industry applications here. We have automotive services, which are EV, electric vehicles, in-cabin charging, mobiles, computing devices. We have home appliances, other consumer devices, multi-device chargers. We have smart home. We have variables, medical, industrial, infrastructure, and robotics as well. The new one that we have added to the panel here is on the retail sector as well. So that's the coverage of our wireless power market here. Let's now go into what the market is all about, what the technology is about. Let's look into how the technology has evolved over the last few years. Example, if you see here, what we have on the wireless power market, we have market segmented firstly into 2 or 3 power levels, if I may say, or the frequency levels. We have low frequency solutions, we have high frequency solutions. Then we also have a uncoupled distance charging as well. Within the low frequency solutions, as we rightly know, as we popularly know, we have magnetic induction, a Qi-based technology, which is a tightly coupled technology. The key industry body promoting this technology, providing the standard, is the Wireless Power Consortium. Then we have within again in the same low frequency band, we have magnetic resonance, which is a loosely coupled technology, basically focusing on electric vehicle has applications, even though it's spreading across other devices as well very soon. SAE, the Society of Automotive Engineers, is one of the industry bodies who's working on the standard so that we can get it out in the market and the mainstream technology well. Now coming to the high frequency, we have magnetic resonance. Again, it's a loosely coupled technology. The industry body who's working on the standard is the Airflow Alliance. And apart from that, we also have for each of these technologies, there's not only industry standard, but we also have proprietary solutions available in the market as well. There's mention about key applications and power classes. I'll just come to that in a minute. Within the high frequency, we also have another technology called Nfc Wireless Charging technology. NFC is relatively new from the wireless charging perspective, but as we know, NFC has been here for so many years. It's a loosely coupled technology. The NFC Forum is the one body which looks after the standards for this technology. NFC charging, again, it's a very focused technology, very clear with regards to what it wants to achieve or what is the application roadmap here. It's basically the small battery powered devices that we have here. So these are the low frequency, high frequency solutions. That again, within the broader segment is the uncoupled technology, as I would segment it, or the distance charging here. And within this segment, what we have is you have 2 or 3 different types of technologies available currently in the market. These are most popular ones. There are many others as well. There's the RF based, like radio frequency based technology. We have ultrasound. We have infrared based technology as well. And there are companies across each of these segments who are catering to these section of the market here. It's again, no coupling is required for this type of technology. There's one industry body who's working on that standard, which is the Airflow Alliance. But again, there are individual proprietary solutions for each of these solutions as well. Again, when you look into the uncoupled technology, the solutions are basically segmented to a near field solutions, or we have mid field technology, or we have the far field technology as well. So this is broadly on the technology front here. Again, what you see in the last 2 or 3 years, the wireless power technology market has evolved a lot. If you see there, we saw new technologies coming in. We saw NFC charging coming 2 years back. We have a new standard coming in. Apart from Qi, which is from WPC, we now have Key has been launched 2 years back from WC, which looks after the kitchen standard, the small kitchen cooking appliances there. And if you see the second last row here, which talks about key applications, there's a wide range of applications that is already adopting or is starting to adopt wireless power. And also, if you see the last row here, we have power classes. So it's not a fixed structure in which the wireless technology is being segmented. But now if you see for each of these, whether it's low frequency solutions, high frequency solutions, there are various power segments, each getting to a bunch of applications as well. Very focused, very structured. And again, this has all been evolving in the last couple of years and would continue to do that in the next coming years as well. So we talked about the technology landscape. Let's look into how adoption is expanding beyond smartphones. If you see the 2016 and 17 scenario, we had two applications. Obviously, we had electric toothbrush in a hand which had wireless charging. And then we also had the mobile phone coming up, basically getting more into mainstream or getting more popular after Apple introduced that in early in the year there. So we had two applications there. Within 3 years' time, by 2019, we saw not only electric toothbrush and smartwatches, but a wide range of mobile ecosystem related applications started to adopt or started to look into wireless power, be it home appliances, be it mobile ecosystem, which includes smartwatches, wireless earphones, fitness trackers, infrastructure. We had Qi chargers installed. We have automotive in-cabin solutions there. We had variables. We have industrial IoT segments also having wireless power, and some in the smart home segment as well. So this was the scenario by 2019. But the market is evolving in a much, much faster rate. So, if you see the next 2 years' time, basically, it suddenly springs into not only other applications, but applications like, home appliances, infrastructure market, industrial segments, robotics, defense, telecom, smart home, and medical devices. So and also at the same time, computing devices. So this basically slide talks about how vast, how broadly the wireless charging technology is evolving. And for each of these technologies, for a bunch of these technologies, there are various technology solutions here. Some of them could be charged with the low frequency solutions. Some of them could be high frequency solutions. Some are even using both of these solutions as well. Whether it's low distance, near field, far field, all those technologies which we are adopting there. So from an opportunity point of view, I think there's a lot of scope in the market. There's work for everybody. There's contribution and collaboration by everybody. And we have lots going on. We have a lot of opportunities here. Again, now being a research company, obviously it's vital for me to speak numbers here. So from the numbers perspective, let's see how the wireless power market is. Let's size the market here. From our research, from a wireless power research backed by intelligence service that we have, which is called the Wireless Power Intelligence Services, referring the numbers from there, if you look into the next 5 years or 10 years bandwidth here, the total wireless power receiving transmitters are expected to grow. That market is expected to grow from a projected 725 million units, which was last year, to 2.5 billion units by 2025. That rapid is the growth. Some applications are growing faster than the other ones. There are new applications entering this market as well. At the moment, if you see the 2019-20 scenario, smartphones, electric toothbrushes, and smartwatches are the three big segments. And when we look into the next 5 years' time, what we expect is that the market is expected to increase basically in the next 5 years' time, 7.75 billion units of wireless power receivers and transmitters combined will be sold in the next 5 years' time. So in the next 5 years' time, there's a market as big as 7.75 billion units. And like I said, the market, the opportunity is big enough for us. And here, again, at the same time, if you have any questions on the market segmentations, you know who to reach out to me. My name is Dinash Kitani. I would thank you very, very much for this opportunity. And over to you, Jeff.
Thank you very much, Dinash. And then this is a great, overview of a summarize for the wireless power segment. And I think from our audience, there's an audience was asking, how does the laser-based wireless power transfer place in your ecosystem of study? Is that part of yeah?
Okay, that was a very direct question, actually. But yes, glad. In fact, there, like I said, and we all saw in one of the slides there are so many applications. In fact, I only listed 30, 35 applications there. There are much, much more applications which are ready, which are which shows good sense to adopt wireless power market. And there will be opportunity for every technologies. It's not that one technology is only for one type of devices and everything. So to answer your question, yes, there is a technology which is using laser beam technology as well. White Charge is one of the companies who's promoting that technology, example, I would say. And there is opportunity for those market. We have market estimation also done for the uncoupled distance charging technology as well. So I would say from the adoption perspective, from a shipment perspective, the opportunity is there.
I see. Yeah, because I heard this day with the 5G technology, there are some companies working on the millimeter wave of a wireless charging, which is more of a beamforming, which is closely related to a laser base. I guess it's not identical. And I think there's a Israeli company using the infrared you are talking about. Then it is use a laser-based technology, right?
Yeah.
Yeah. Very cool.
Yeah, and there are many applications. Example, I would say the IoT, the industrial IoT sensor market, or the retail segment market, and few consumer applications. It makes a lot of sense to use distance charging technology, whether it's near field, mid field, and far field. And there are a handful of companies. In fact, not handful. There are plenty of companies who are providing these solutions for these type of solutions.
That's great. Very good. So we have 3 more questions, but for the sake of the time, I think I will save it. And when we have time, we'll come back to that, if that's okay. So yeah, thank you, Dinesh. So so the next speaker is Tom Okada from Witricity. So the Tom is an experienced executive with expertise in building and managing global team and global accounts in technology industry. So he is now responsible for business development for Japan and the US for Witricity Corporation. So primarily focus on enabling wireless charging on the electric vehicle and the industrial automation. So Tom, I will leave the floor to you.
Okay. Okay, can you see the slides?
Yes.
Okay.
That looks good.
Okay, let me make sure I click on the share sound. Yeah, because last time I'll have a internal video to show in the middle of it. So I just wanted to make sure that I set up properly. Okay, yeah, thank you for viewing our presentation. My name is Tom Okada, Executive Director from Witricity. It's a Boston-based technology company that enables electric vehicles to be automatically charged wirelessly. My role at Witricity is to help car OEMs, e-mobility companies, infrastructure companies, tier ones, manufacturers to adopt wireless charging technology. My background is electrical engineering, cell phone design from Motorola in old days, embedded software, and now automotive business development. I'm based in Silicon Valley, and on the side, I do mentor and advise startup companies and also entrepreneurship in large corporations. When you think of electric mobility, there's always a need to charge the vehicles. We now enable these electric vehicles to be charged wirelessly, automatically, without worrying about plugs and manual labor. Electrification is now coming to everything from passenger vehicles, trucks, buses, autonomous vehicles, mobile robots for logistics, factory automation, and service industries. And you see e-bikes, e-scooters, and even drones. Witricity's wireless charging technology enables people to stop worrying about plugging in the car. Just park the car and the charging is automatic. Taking away the cumbersome charging process allows more consumers to decide on purchasing EVs, helping further adoption of the electric vehicles as the world embraces clean energy and electrification. Witricity technology is based on MIT's fundamental IP from 2005, enabling wireless charging of electric vehicles with position tolerance in parking, ground to under chassis gap between the charger and the receiver, and interoperability of the charging system now with the SAE and GB standards set. We also enable bidirectional charging or wireless V2G for smart grid and virtual power plant, and dynamic charging for moving electric vehicles. We offer MIT, University of Auckland, Witricity, and Qualcomm Halo IP portfolio, as we have combined Witricity and Qualcomm engineering together 2 years ago. And we're enabling wireless charging applications for many applications, from consumer devices, medical devices, industrial and mobile robotics, electric vehicles, and even electric ships. Wireless charging is now standardized by SAE and GB. SAE is in the United States, GB in China, allowing for interoperable split supply chain between vehicle assembly and ground assembly. So people can make car wireless charging, and then people can make ground systems, and they'll interoperate together. IEC, ISO, UL also have wireless charging standards enabling interoperability and safety regulations. Witricity provides IP and reference design for electric vehicles. We support car makers around the world with tier ones and infrastructure equipment manufacturers listed here to supply the wireless charging equipment. We're headquartered in Watertown, Massachusetts, and we have a development center in Switzerland. We have representatives in Germany, China, Korea, and I'm covering Japan and the United States. The company has been around for a while, so it's hard to call it a startup company, but we just recently received a $52 million funding in a funding round. We're ready to accelerate the progress in adoption of the wireless charging system, and also making equipment ourselves as well. But you can see that in the past we've worked on consumer devices. So Dell Computer has announced adoption of FOWP standard-based wireless charging system in 2017. In 2019, we combined with Qualcomm Halo, and now we're one-stop shop for all the magnetic resonance, IQ, magnetic resonance IP portfolio. The adoption of wireless charging in electric vehicles starts from residential and expands to public infrastructure. It also allows for high power charging for buses and trucks when 50 kilowatt to even 300 kilowatt power is needed. As EVs get adopted in fleets and autonomous vehicles, will enable power snacking, where vehicles get charged as they roam around or stay in queues. Autonomous parking and wireless charging enables autonomous valet parking with autonomous wireless charging. So we can enable premium experience vehicles. I'll show you the video BMW 530e soon. That was launched in 2018, and some people may know, last year Mcgellar launched wireless charging, embedded the Mcgellar Speedtail. Now we're expecting to see a few additional manufacturers to launch wireless charging enabled embedded electric vehicles from late this year to next year.
BMW is the first car manufacturer providing wireless charging for your BMW 5 Series i Performance. It's the comfortable way to charge your BMW plug-in hybrid.
This was launched in 2018.
Blue lines in the center display guide you to position your BMW above the ground pad. As soon as a green circle appears, you are directly over the charging plate. When you switch off the ignition, the charging starts automatically. And this is how it works. The primary coil in the wireless charging station generates an electromagnetic field. The secondary coil in the car then transfers the energy to the high-voltage battery pack. A completely empty battery is fully reloaded within 3.5 hours. BMW Wireless Charging makes charging easier than refueling.
Okay, here's another example. So Hyundai Motors shows a video of Auto Valley Park that I mentioned earlier. Okay, so you can see the kind of use case applications of wireless charging into autonomous parking application. So as EVs increase, there will be more need for wireless charging. So we're expecting some of these statistics that I'm sure you've seen before, but we're expecting to see an increase. Probably, recently there's probably bumped up. A forecast is bumped up further for the electric vehicle adoption. Based on the capacity capability of the U.S. power grid, most charging will be done by level 2 charging, even though people are adding DC fast charging, but it won't be available everywhere. And that's the area. The level 2 charging is the charging power that's been set by SAE and also GB standards. With the increase of EVs, we see the increase in charger demand, boosting the need for wireless charging in the next 10 years. The best application of wireless charging is autonomous EVs, as they need to be charged autonomously. Wireless charging is available outdoors in any weather conditions without a concern of connectors getting dirty, while conductive charging will need to be done indoors with a clean vehicle. So you can see the application in smart cities, wireless powered urban transit, shared autonomous vehicles, and all enables bidirectional charging. Witricity has demonstrated greater than 90% grid to battery efficiency by bidirectional charging using SAE standard coils. Wireless V2G will allow EVs to be plugged into the grid, enabling smart grid and virtual power plant, which will be critical for enabling renewable energy in the smart city going forward. We're now working with car OEMs to develop wireless charging systems for R&D and also commercial SOP programs. We expect to see many car makers and smart city autonomous shuttle programs to adopt wireless charging as EV fleets and autonomous EVs take off around the world. Well, this is our CEO, Alex, says simpler always wins. Once the technology goes wireless, it stays that way. You'll never want to plug in again. We have additional information. If you go to our website, you can see some of these YouTube videos in our website to show you the explanation of the wireless charging and how it enables the electrification of autonomous vehicles and other devices. So thank you very much for listening to my presentation.
Great, thank you, Tom. I think one of our audience are asking how do you address maximum power communication to communicate efficiency for the EV charging? So is that something through mobile, or can you elaborate a little bit?
Yeah. First of all, the power level is set by SAE standards, and there's WPT 1, 2, 3, which is like 3.7 kilowatts, 6.6 kilowatts, and 11 kilowatts. And they're also working on 22 kilowatt systems. So the transmitter and receiver, first of all, the system has to be capable of some power. So let's say there's 11 kilowatt enabled WPT3 system available, and basically when the car and the vehicle side and ground side meets, they communicate wirelessly, through Wi-Fi channel, whether what kind of vehicle it is. If the vehicle is ready for only for 3 kilowatts, it says, okay, I'm a 3 kilowatt charger, so don't please deliver me 3 kilowatts. So that's the kind of a communication protocol that takes place between the vehicle and VGA, and that's set by the SAE 2954 standard.
I see. Well, thank you for that. And then actually we do have a time for one more questions. So people are asking, what is the efficiency related to plug-in charging, both in terms of charging time and energy consumption in general compared to wireless?
Well, so wireless power transfer. This was actually there was also a session in the morning by Francisco from former Qualcomm VP explaining about wireless charging. So the typical efficiency between the vehicle and between the vehicle or battery to the grid or grid to the battery is around 90%. So the standard says it needs to be greater than 86%, I believe. But typically we can achieve 90%. Coil to coil efficiency can be very, very high, between 98 or 99%. So so the entire charging system, the loss comes from the electronics primarily. Between the coils, the efficiency is very, very high.
Okay. Well, thank you. So I think, thank you, Tom, for the presentation. And I think the video actually shows nicely of how the wireless charging is going to be enabling future the autonomous driving experience, right? The idea is totally, no human intervention for everything. So thank you. And as for next speaker, so I would like to introduce Simon Mcgellar. So Simon is a chief operating officer at Era, inventor of a free power, a free position wireless power solution for at home, in car, and a common space device charging. So he has spent over 25 years in electronic hardware in large companies such as Honeywell and Amcor, as well as leading a number of successful Silicon Valley startups as a CEO. He has spent close to a decade in wireless power, having been a CEO of Sonic Energy and an early member of Energis, so prior to his role today. So Simon, the floor is yours.
Thank you, Jeff. I'm going to share my screen. Just please tell me if you can see it.
Yes.
Well, thank you for that introduction, and good afternoon, good morning, good evening, good night, all over the world. So we have at Era a simple mission to pioneer the most advanced wireless charging experiences. It's a simple sentence, but it's really focused on two words: experience and advanced. So everyone in this panel, many of the people dialing in today are practitioners of wireless power transfer, but all of us are users. And I think all of us can claim to be frustrated by what was overpromised and undelivered for years in wireless charging across sectors. And a lot of money was poured into this industry a few years ago. And so we set out from the start. It was founded to fix the problems. And to do so, you have to take a very advanced approach. The approach that we take is a ground up, full stack hardware, firmware, software approach. We do everything in-house in Arizona, and then we subcontract it out to manufacturers around the world, to the level of advanced magnetics and supercomputer number crunching to put these systems together what you're looking at there on the right-hand side is a control board and some of our unique coil architecture. Our technology is full surface wireless charging. So it enables free position, multi-device charging, phones, peripherals, accessories, mobile devices, anything you carry on your person, everything you bring into a room, into a conference room, to your desk, into a car. I'm going to start with a general update, but then I'm going to pivot off Tom's work on under vehicle charging and talk about our work in cabin charging. As I said, we do ground up engineering. We have 80 patent assets. But one of the things that we're most proud of is that we have product in the market, and we're obsessed by the customer experience and the customer feedback, and essentially making the issue of charging go away. That's what wireless charging is all about, having always on power. So the comments that we get are that it fixes wireless charging, that it puts to bed issues that people have had for years, and finally delivers on the promise of wireless charging that we've all said for years. So we have received quite a number of awards. These are all recent. I don't put this on here to impress you as much as impress upon you that wireless charging is still front and center in the tech media. It's front and center globally. It's a problem that people want to solve, and it's a problem that needs to be solved. So we won a CES award this year for our embedded technology, and our partner won it for mobile devices and accessories. Our CEO and co-founder, Jake Slatnick, was awarded on the Forbes Next 1000 list. And very recently, we were listed by Fast Company and ranked #5 in the world's most innovative companies, and alongside names such as Apple, Samsung, AMD, Google, etc. What's really prominent about this is that it was for fixing wireless charging's biggest annoyance. So whether we like it or not, we're fixing, this is a convenience play. We're fixing a worry, we're fixing an annoyance. We're putting something to bed for people that they've had enough of. And that's our obsessive focus. Our segments, and I'd like to thank Dinesh for providing this slide to me. We focus on the mobile ecosystem, wearables, computing, in-car mobility, and common spaces. So hotels, restaurants, and embedded solutions in common work areas or due to the pandemic, at home working environments. So what does that look like to the user? Well, it looks like, in one example, a desk that powers everything. So from your laptop, tablet, phone, accessories, earbuds, even your lamp, or even warming up your coffee, being able to place your devices without accurate alignment in any orientation and just have charging happen. So it's seamless, it's invisible, and it's everywhere. That's an experience that people want. In common areas, same thing, the ability to charge in these pods throughout the space. If it was in a hotel, in your room, in the common spaces, in the food and beverage areas, in the lobby, in meeting rooms, conference rooms, same underlying technology, same ability to charge different devices, different phones, different peripherals, different headsets, and to do so without accurate alignment and having to worry about that to check your battery levels. Of course, as you go to bed at night, doing what I do is literally throwing my stuff onto our technology, but by my bed, and waking up in the morning when I'm refreshed, all my devices are refreshed. Again, just a simple experience, making it seamless and making it elegant is what it's all about. And then what I want to finish off talking about for the rest of the presentation is probably one of the most broken areas in our world, which is in car. And Tom and Electricity are elegantly addressing underneath the car, and we're addressing inside the car. And so if we've all driven cars over the last few years. If you've rented a car, you know that getting into it with your phone is a really interesting experience. You know that every time you buy a new phone, you don't want to have to buy a new car to go along with your new phone, but you almost have to because they're very incompatible. So common surfaces in cars, so center consoles, front consoles, side consoles, giving the car OEM designers the freedom and flexibility to design to their design guidelines and making any surface active in the car or multiple surfaces active in the car so that you can basically throw down your phone, your earpods, your keys, your coins, your credit cards. You don't damage your credit cards. You don't heat up your keys. You don't have to worry about placement accuracy. You can have small devices, large devices, multiple devices. And, if you're driving a fast car like a McLaren, which I don't own, Tom, and go around a corner very fast, if your phone shifts, it still keeps charging. So what is broken in vehicles? It's pretty intuitive. So legacy wireless chargers look like this picture on the left. They are cubbies, they're sockets, they're pretty inelegant little sections where you place one phone, and it's based on today's technology, so it doesn't scale to future models very well. It's for single devices, typically supports a limited number of power profiles. It's very constrained. It's very constrained from the design perspective, and it's very constrained from the user perspective. There are also some industry-wide issues like key fob interference and EMC issues across the board that need to be solved. A free power wireless charging surface, it allows full freedom of placement and fast and accurate design, device detection and localization of those fields so that they charge multiple devices, thin profiles so that they can fit in any location. And very, very important, forward compatible, so that as each new release of phone or other mobile device comes out, the transmitter system can be upgraded, just as many systems are in cars these days, whether you go to the garage or you do it in your own garage, to support new phones and new protocols. And that makes the cars future-proof. So if you're building a car with a 5-year ownership cycle, you don't have to worry about the next generation of phones. And it's just a much better experience for the OEM and a much better experience for the user. So how free power compares across the industry, our approach has been to look at this from features that are user-facing, user-driven experiences like freedom of placement and intelligent charging management and elegant customizable surfaces, but also looking at features that are on the deployment side. So, obviously it has to be efficient, it has to be thermally efficient, it has to be scalable, it has to be relatively low cost, and most importantly, globally compatible. And the hardest one, from my experience, is passing regulatory standards, and all of them across the board. So over the air, and I've worked in it before, it's the dream. It's the dream of walking into the car, walking into the room, having all your devices start charging. But it is very difficult to deploy, and it is extremely difficult to get through all the regulatory testing. Traditional Qi has won the standards war for a good reason. You can tick off the boxes for passing regulatory standards. It's got great global compatibility, and it's relatively low cost and provides a scalable platform for efficient power transfer. So what we did with free power is we married the two. So we looked at the experience that the user wanted, and we looked at the experience that the OEMs want to deploy the technology, to make sure that before we even launched our first product, that it had been designed to be regulatory compliant. It is globally compatible because it's compatible with all Qi products as well as others. And it scales, and most importantly, it provides very efficient power transfer. And so to do that, we have custom controllers. We support multi-device charging, full surface freedom. That means that we have to track devices to very high accuracy, know what needs to be charged, what doesn't need to be charged, differentiate between different types of devices. We have a unique topology and precision power delivery. Again, Users don't want to experience a time lag between placing their phone and seeing it charging, or any device, and it's confusing. So low latency and the ability to have devices move around and keep charging. Advanced thermal algorithms, and of course, firmware upgradability so that the transmitters are scalable across future generations of receivers. We also have a modular architecture, which allows us to scale from a chipset to multiple devices. And very importantly, particularly for automotive, any shape or surface or size, and also including distributable architecture, so that we can have essentially satellite stations, maybe even a cup holder, or different stations driven off the same controller. Obviously, we support all the major protocols, and there are some real key things that you need to tick off if you're going to be accepted into a vehicle. EMC efficiency, because you're driving it off the battery, foreign object detection and management, key fob interference, which is a huge issue right now, and the need for a universal solution, and multi-device charging. So just some examples of the possibility that this affords the OEMs, the ability to have in, let's say, that center console, no dead zones, for example, or future proofing. We know the phones are getting larger and smaller, so there's large models and small models coming out, so people don't have to worry about that. Multi-devices, maybe one's an Apple, one's a Samsung, the ability to rotate these phones. Let's say you get into a rental car and you want to put it in from portrait to landscape mode to run a GPS, just don't have to worry about that. Or like I said, driving a cup holder to warm your drink while you charge your device. It's all very possible of the same architecture. So the proof is in the pudding, of course, and the solutions in the market right now, just showing benchmarking, which we do. We have a robot testing system. We test about 2 million data points on the surface. So we move our devices in tiny increments, collect an enormous amount of data, and that's how we provide these tools to our implementers and to our customers, so they can get the experience and they can actually use that data and port it into connected car or port it into IT systems. But it also helps us to benchmark. So 2 benchmark products right now. This is a Panasonic moving coil system. The coil literally moves to find the sweet spot of the phone or other device, pretty much the phone. But it's a large device, it's thick, it has a fan, and this colored area is the efficiency map, and this is the active area, and this is 2 scale. So another charger that's in the market is a 3-coil charger. You can see that it expands the zone a little bit, but then for actually not too different a price point, you end up with our charger. This is our Gen 1 system. And you can see across our coil architecture that you have a much larger scale of charging area, and the efficiency is very strong too. And finally, as I was saying, we provide tools. This is an intelligent system, so it's not just dumb charging. It provides data, big data to the users. So whether you're running an enterprise system or you're simply porting it up to the car, or for engineers to debug this in their systems before they deploy it to their vehicles. We have tools that allow you to visualize the coils, to benchmark, and to get the full experience of our system. So thank you for your time today. I know we will only have time for a few questions, and please reach out to me separately afterwards. And thank you for the opportunity.
Thank you. Thank you, Simon. Thank you for your, this is a great presentation. I think so we have time just for 1 questions, and I think we'll have 2 questions, but you addressed one of them with how your system is forward compatible with the Qi or air fuel alliances, and we can come back to that. But what are the power levels that you are capable of providing for the phone charging today, and also how do you see it for the future?
Well, we currently support up to 15 watts. Currently, we support all the protocols. So every time there's a new phone coming out, we support that, and we do support all of the WPC protocols. The ability of the technology to scale, however, we can scale up to about 100 watts over about a 1 square meter area. So devices beyond phones to laptops to even small appliances.
I see. Well, thank you. No, this is great. So thank you for your time. And as for our last speaker, Ashish Mehta. So Ashish is a serial innovator that has 8 years of experience within National Instruments consulting on system level solutions and representing Association of Southeast Asia Nations as its industrial Internet of Things and a big analog data expert. So Ashish, I will turn the floor to you.
Thank you very much for the introduction, your time, inviting us to speak as well, and for everyone actually attending this session as well. Thank you so much for your time. Are you able to see my slide right now?
Yes.
Perfect. Well, the company, just to kind of dive straight into it, the company is called Transify, and I basically started the company with Dr. Reza to focus on creating long-range, safe and efficient wireless power network technology. Our vision, though, is to provide access to power to anyone, anywhere, anytime. That's the vision of the company. We started in 2017. We're only 3 years old, but yet we have turnkey products right now that can be that's already being purchased, being sold, being deployed, which is super exciting. I think the big thing is that, you know, as Transify, our core is to create a whole wireless solution, a wireless nation, removing and untangling the world from any form of cabling infrastructure. It could be either data or wireless power. Now, data is obviously quite well solved, very mature. So our core focus in terms of innovation, patents are all within the wireless power realm. Now, I think it's important to be able to, when you look into wireless power, it's always important to be able to look into where we're at in terms of technology, what we're developing, when we should be developing, what we should be developing, and so on. So I think this is something which a lot of you probably seen, you know, back in books or innovation books or from school, from MBA programs, whatever it may be. But essentially, it's a chart that kind of showcases where we're at in the innovation cycle. Now, wireless power transfer for far field, long range, essentially radio frequency based wireless power transfer is still in the innovators' early adopter stage in terms of customers, users. We are not quite in a majority stage as yet. Now, when you look into this, I think the big thing that you have to really start looking into when you look into wireless power transfer or far field is that if you're developing any technology in this area, you need to have turnkey solutions. Solutions that are, you know, people can actually use directly, that's robust, that's reliable, high data quality, and shows some sort of solving some sort of like desperation problem, showing ROI. So these are all important parts when you're in an early adopter stage when it comes to technology. And so that's something which I think a lot of people have not seen within the wireless power transfer world, is that we lack a lot of turnkey solutions right now. And that's something which we have focused on a lot. The next stage, once the adoption has taken place, the technology has a lot more confidence and maturity, it's starting to look into lower cost solutions, smaller form factor, and being able to have flexible solutions. And that's going to be something which we will also look into is the semiconductor plane. And that's something which I think everyone's super excited about. And hopefully we'll get that pretty soon and have turnkey solutions in that particular area. And then after that, obviously, we want to look into new materials for higher power type of capacity and so on. So I think the reason why I brought this up is because I just want to be able to set aside, or at least set the landscape of wireless power transfer when it comes to timelines, adoption, where the technology is at. And for us, obviously, we have focused a lot of our time in the adoption scale. So being able to create something as turnkey within specific niche area, and in this case, it's industrial IoT. Now, we saw power as one of the most important backbones for the industrial revolutions, basically. The first is all about steam engines, second, all about AC distribution, third, inverter control systems. And now we're in the fourth industrial revolution where we're looking to turn this physical space into a digital economy. The reason why we're doing that is because we need infrastructure for autonomy. Autonomous systems needs a digital infrastructure. For that to happen, you need mass sensor deployments, right? So that's something which I think is difficult to do. I think we've been looking into IoT for quite a while. Since my first job in National Instruments 07, we've been talking about 1 trillion devices going to be deployed because of wireless solutions. But battery technology is supposed to take that step, but it didn't. Our predictions for IoT has been reducing every few years. So this is where wireless power transfer comes into play, solving a very core problem that people promised and it never really happened in terms of scale. And that's, industrial IoT applications. Now, if you can look into industrial IoT specifically, you'll start realizing that actually, wow, there's a lot of cost going into cabling infrastructure, because right now, 94% of industrial IoT systems are still cabled. Batteries are supposed to take over this massive chunk of labor cost to cable, but it didn't really happen, mainly because you had to take a hit in data quality. And also at the same time, you have to add maintenance schedules to be able to maintain those batteries. And this is where wireless power transfer comes into play, where we can disrupt this 80%, at least 80% of this chunk of labor costs and installation costs, allowing for more room for intelligence, such as the software, the PLCs, the program, the embedded systems, and so on, to be able to grow that and scale at the same time. And that's what we're focused on as our core niche area for adoption. And that's what we've done. We've created a solution right now that's turnkey. Basically, this is our T5 wireless power network for industrial IoT. We have our gateway systems, IoT sensors that are universal. We're handling both power and data. We've deployed the system all over the world. This is done in 3 years, under $1 million worth of investment as well. So that's something which I think is very, very, very focused, very niche for us, what we've done. We filed 3 patents. We were also published in, EE Times, The Economist, not published, but I mean, he's mentioned National Geographic, magazines in Austria, Everything RF, Energy Watch, and so on. So I think the big thing here is that, it's nice to be able to create technology, but in the end of the day, if you don't have a turnkey solution, it's very hard to be able to get people to adopt the technology. You need the utility for the technology. And so this is something where, we'll kind of dive a bit into the utility, what we've developed. Essentially, it's a very basic, not very basic, but very standard IoT system. You have the T5 gateway, which is basically acts like a normal IoT gateway. It does wireless power transfer to power up the T5 sense nodes. The T5 sense nodes has multiple sensors on board: temperature, humidity, pressure, 3-axis acceleration, acoustic, TVOC. Being able to do some core measurements for industrial applications. And then the data gets pushed back to the gateway, and the gateway then pushes the data into third-party cloud systems using multiple protocols, or even general clouds out there, such as Google, AWS, Mosquito, and so on. And plus, we have our own local web services dashboard, which is using basic Grafana. It's fully customizable, and you can actually monitor, analyze, and be able to also create reports for your data. So a very basic IoT system. But in the background, you have the wireless power network feature, and no one has to care about it. That's the importance, where you can deploy the system. So users have already deployed our system and literally just press calibrate, automatically finds all the devices, powers it up, manages the power levels, distributes a network of power without any issues whatsoever. And that's something which I think we're super excited about, and that's what we're constantly improving on and developing. Obviously, the part that customers or users can program if they want to is the data part. So the power just happens like a wire. It powers everything up automatically in the background. No one has to worry about it. Obviously, with the data, you can actually add your own analytics. You can actually add different sort of firmware into your sense nodes and be able to do analysis or alarming or even certain types of FFT and so on. So, whatever it may be, like a normal IoT system. Now, what we have created is really more of a platform-based approach. What we focused on is creating the core software, the algorithms that allows for the wireless power network to work. Now, obviously, hardware wasn't or is not as available as what we expected initially. So we had to create hardware from the ground up as well. So from the circuit board, from the beamformer circuitry within the gateway, the rectifier circuitry within the receiver, the sense nodes, the sensors itself, the whole data structure, data recovery structure, everything, all developed from the ground up. But in the end of the day, though, we are finding partners on the hardware side. We are willing to provide that what we've learned in the hardware aspect to provide, the architecture for this to be developed, make it a lot cheaper, more robust, and a lot more accessible to the world. So it really, in the end of the day, it doesn't really matter what market you're going after. It could be heat mapping, building management system, predictive maintenance, consumer electronics, automotive. Our algorithm's all the same. It doesn't change. All they have to do is really change the hardware to suit that particular market. That's it. So that's the platform-based approach that we've taken for wireless power network. So we're not only hardware agnostic, we're also application agnostic. The applications that we are focused on, though, has been heat mapping, building monitoring systems, and condition monitoring. The reason why we focus in these areas is because these require high data quality, but also at the same time, larger or scalable sensor solutions at the same time. So that's something which we have seen value, and that's what we've seen where we can enter the market in terms of showcasing ROI for wireless power transfer in far-field technology areas. We do have certain customers within automotive, medical devices, and consumer electronics that are NRE based, so customization. So we charge NRE for that to be able to customize certain needs for that particular market itself. And then that's obviously volume, we will lock in volumes of orders down the road. In terms of hardware, as I mentioned before, we've developed everything from ground up. This is actually already published in Power Electronics. You can have a look at the circuit boards. We developed our own 8-channel and 16-channel beamformer hardware from the phase shifting circuitry all the way down to the splitter systems, and being able to really have a robust beamforming system for 9.15 megahertz, well, between 840 to 960 megahertz, which is quite cool. And this is not available right now in the market. You can't really buy it. And then we also developed our own rectifier system. In this case, it's a 4-channel Turin-1 rectifier with the power management circuitry as well. We didn't use any specialized chipsets. It's all discrete circuitry, which is a lot more efficient, a lot more custom to what we are doing it. So what we did was we took the application and then focused on the application, what's the requirement for the application, develop circuitry around it. And that's what we did. That's for the hardware side. So hardware has to be very, very focused towards applications. And it's deployed, right? So that's a big thing. So we've deployed the systems all across corridors for monitoring sound, heat mapping, for utilization of doors, people entering buildings, entering offices because of COVID-19. Customers or property management companies wanted to be able to understand a bit more about crowding, how many people are actually entering the office rooms, and if there's any specific areas where there's a lot more people than usual, a lot more activity than usual. These are some sense nodes that are deployed in conduit areas. And I think what's amazing about this is that you don't have to worry about how it's orientated. It's these systems here are using omnidirectional antennas, so it allows beamforming in a 360 degrees, which is a cool part. Case studies. So obviously, in the end of the day, these things have been deployed in actual environments with that's been tested by pretty established companies. So Schneider Electric, this was deployed. By the way, this is actually old hardware. This is not our current system, but essentially, it was important for them to be able to actually see if wireless power can actually replace cables. And in fact, this gateway here was pretty much like a 24-inch LCD panel here, which is quite huge, or is large. But still, in the end of the day, for them, it's super important to be able to remove cabling infrastructure. So this has been running for more than a year in Schneider Electric's cafeteria, powering up sensors and HVAC systems on the machines over there. And the data integrity at the moment, all the data gets pushed to their BMS system using Modbus. And the data integrity has been fantastic for them. More than 80%, actually 90% or so of data quality, and it's way beyond their benchmarking, which is really cool. So far, we're working with Schneider Electric to develop strategic sales with them in terms of the enterprise solutions that they have. This was another one for vibration monitoring. This is actually a fabrication system for pipes. Basically, a pipe boring system where it is a drill boring holes into rods to create pipes for oil and gas, which is really cool. These guys were actually doing handheld devices for vibration monitoring. So there's a drill bit on there. There's actually pipes that can crack, and they would miss this a lot of times. Each pipe can cost about $100,000, so it's expensive. So they looked into batteries for vibration monitoring. When they implemented the battery solution, it only lasted 6 months to actually get the right data to detect faults. 6 months, that's it. Now with cabling, they actually looked into cabling each of these machines. It would have taken 2 days of downtime in the machine. These are 24-hour machines. For a small and medium enterprise or for a small manufacturing company, any downtime for a 24-hour machine is a huge loss. So sensors were a really hard thing for them to implement. So where we went in there, we actually implemented the system all within 30 minutes while the technicians were working. And we were able to get all the FFT data that's required to detect bearing fault, shaft alignment issues up to like the 20th harmonic. And that's something which is really hard to do without cables or cabled power supply. This is another one in Yokogawa. So this is actually on top of their building, where we actually deployed T5 sense units on top of their machines, the motors. What's cool about this is that, it's all about the data. We were able to sample at 1.3, 1.4 kilohertz of data from X, Y, Z coordinates, multiple test levels, compared with ISO charts for the machines, determine whether the machine's within good health, satisfactory, unsatisfactory, and based on that, if it's unsatisfactory, we would actually produce an FFT analysis of that data up to the 20th harmonic, where this gets sent to either an AI system for analysis or a vibration expert, where they can tell whether if the machine has a bearing fault, has a gearbox issue, has some sort of loose bolt or whatever it may be. And before actually opening up the machine, they can actually order the parts. Then as the parts arrive, they can maintain the machines, replace the parts at the same time. Usually what happens with a wireless sensor is that these get measured, an alarm gets set off. Then the crew would have to go in, open up the machine to figure out what the faults are. Order the parts, wait for another 2 months or 3 months, and then be able to replace the parts. So that's about 1 or 2 months minimum of downtime of the machine itself, which is ridiculous. So that's why a lot of these systems are wired. Wireless is not a way to go. And so with wireless power transfer, you're able to kind of get the same data quality as a wired solution and be able to have the freedom of being wireless. This is another one for a gantry system, which is really cool. This is a moving gantry within a manufacturing facility. Now, if a gantry goes down, essentially a manufacturing facility shuts down. People go home. Now we have a gateway, which is this G here. It's powering up sensors on the gantry for vibration analysis and also sensors on the gearbox manufacturing line. So yeah, I mean, basically, this is robust, reliable, high quality. Our algorithms in the background is able to detect any movement or any alignment issues when it comes to the sensors and recalibrate for that particular new position. It's fast enough to do that. It's an AI system. This is what we patented. And that's where I think the biggest problem right now with wireless power transfer is being able to actually deploy these systems in a commercial setting. That's turnkey, that people don't have to worry about. This was actually deployed by, within about 1 hour or 2 hours, and the calibration took about 10 minutes itself. So the gateway over here, it's using the 16-channel gateway because the distance, does require a bit more. It's around 15 to 20 meters away, I believe. Obviously, with great power comes great responsibility. This is a team. Dr. Reza, co-founder, CTO, spent about 8 years focusing on his postdoc on wireless power transfer optimization from near field, mid field to far field. Myself, I spent 8 years in industry working on embedded systems, IoT. I was an FPGA expert in Austin, Texas, and then I moved to Singapore, which is my home. And basically over here, I spent a lot of time managing marketing teams, engineering teams, and so on. We brought on Siddharth and Lionel to really bring on and take the prototypes that myself and Dr. Reza created and commercialize it. Siddharth has about 12 years experience in commercializing prototypes, or he's an industrial designer basically from Carnegie Mellon University. His expertise is actually getting to manufacturing, and Lionel an operations side for manufacturing. And then Stephen, Mayank were all brought on board to focus on embedded development, software development, just to robustify the whole software platform. As for advisory team, Dave Smurkowski, serial entrepreneur, sits in Seattle. He, why we brought him on board is because he was the CEO of Sensor Motion. He spun off that company from NASA's Jet Propulsion Lab. He also was part of Boeing Venture Fund, Berkshire Hathaway. He started up Exostar, which is basically handling more than 60% of the Department of Defense contracts. Chandan Nair, he is one of the most effective sales organization builders in National Instruments, which is really cool. He built the whole Asia Pacific area, which is the highest growth area for National Instruments. And Dr. Jamari, a technical advisor, he has more than 48,000 citations in wireless power transfer optimization research. So yeah, by far the #1 in the world in this area, which is quite cool. He was also named by Thomson Reuters as one of the most influential scientific minds 3 years running. Yeah, so basically at Transify, what we're looking to do is create the next revolution for power connectivity, whether it's building infrastructure, industrial IoT, or even grid infrastructure to be able to distribute power accordingly. We want to be able to create a standard for wireless power transfer for the future. Thank you very much. That's pretty much what I have. Hopefully, I didn't take too much time.
Yeah, great. Thank you, Ashish. This is great, and I think it's great to see the angle from the data transmission perspective, and then you work your way back to the wireless power side, which a lot of sensors these days are consuming less and less power, right? So a lot of the time you don't really need to have a very meaningful or a high power for the sensor. So I think this is a interesting and a great approach. So I think the time is tight, and I think there are a few questions for you. We will compile the question, and then maybe later after the group questions for the panel, we can come back to the question you have, to the question the audience have. So yeah, so thank you. So I think this is all of our 4 speakers, and then now for the rest of the time, we will actually just have a general platform as a panel to ask all the speakers questions. So this is to the audience. If you have any generic questions, please just feel free to enter in the chat room, and I will actually relay them for the time being. But I will start with my questions, which is as generic as possible. And I would like to ask for each individual of you, what are the current challenge you see that prevent the fast adoption of the solution of your company provided? So please address them in terms of a technology hurdle, regulatory uncertainty, and or the market signal. So yeah, so I think I will start with Dinash, even though he's in the market. So Dinash, I think we will start with you as to give an overline of what you see in the market and what are the challenges you see for the fast adoption.
Yeah, sure. Thanks for that, Jeff. A very interesting question. And again, I would refer to the 3 other panelists' presentations when we talk about this. And as we all know, this technology is more like an emerging technology. It's a very new early stage adoption. And we have already reached a certain stage, but that is not the stage that we have to be. In fact, there's a lot of development advancements required. One simple example is that a couple of years back, or not a couple of years, 4-5 years back, we had a 5 watts charger example in the market. But now, as we see now, the market has evolved from a 5 watts to 15 watts, 15 to 30, 20, 40, and 50 watts, especially from the phone ecosystem. And again, there is not a simple standard. If you see the IDAS technology, we have seamless technology. We have, free power technology. There's more spatial freedom there. So again, to answer your question with regards to, where the technologies advancement is there, I think we have a long, long way to go. One important point which I want to mention here is that, again, I would like to say that wireless power technology is not about just putting antennas and coils into any devices. It's more about spatial freedom. It's more about user experience, and it's all about, providing interoperability in the market, or also at the same time, providing less restrictions. So it's very important that the standards are developed, the products are developed, which takes care of the user experience, not about, okay, I want to have my chip into that device. I want to have my coil or antenna into the device. So that's one factor. The second factor, which I think Ashish also mentioned, that it's not about, if suppose when you try to compare, which is what happens many times, or if I'm adopting wireless power, the cost is this, it will increase by $2, it will increase by $5 or $20. I don't think if you look cost by cost, or cost to cost, like to like comparisons, we will never get into the adoption stage. There'll be no device that will be able to adopt wireless power. So example that Ashish which gave is that, if you get wireless power into your device, or into your ecosystem, or into your factories and all, example, you get rid of the maintenance costs, you get rid of the lockdown, or in fact, when I say lockdown, I would say downtime of the factories and all those things there. So I think we have to really present the technology in such a way that people understand the value, the users understand the value, the businesses understand the value in terms of increasing efficiency and productivity into the system there. So I think it's very, very important from the adoption perspective that we present the right picture, we pick up the right applications, and more important, we deliver what we promise. There has been a lot of over promises been done in the past, with what we can do and what we cannot do in terms of things. And now that wireless power is getting more into reality, I think we have to be very straightforward in terms of what it can actually achieve and what we can deliver as well. I hope that answers the question.
Yeah. No, thank you. I think that's a great summary.
Here, Peter Watt here. I promise you to see that you see me back within 80 minutes. We have 80 minutes right now. Let's do the more fun stuff before people really vanish. All right. A lot of people.
Yeah.
So please, Jeff, allow me. What we're doing now, we are doing the Raffle. The Raffle is coming now. No, I tried to. Raffle is coming now. We raffle off this floating wireless lamp, clearing, right? So I stop my sharing again. And in the background, while you were speaking about this, we had a random number, and the number was picked by Jim Warner, or for Jim Warner. Jim, are you here? I see you here.
I am here, yes.
Oh, Jim, congratulations.
Thank you.
So far. Send me your details, please, to peter.walter or just peter@WCA.
Okay.
Jim, and we will send you this lamp.
Okay,
that
thanks.
is pretty cool. That's a pretty cool lamp.
And perhaps you can send us a picture when it's somewhere on your desk and it's in operation. Yeah.
Okay.
With this, hey Jim, there
yeah, and Jim, be free to ask questions to Peter. What technology is that? What solution? What frequency is that? So.
Right. So with this, I go back again in my sleep mode. Jeff, continue, please. Jeff. One information: we are not shutting off this conversation. I think we said it should be over at 5:30. But if people are still there and we have questions to be answered, we do this. I know that one or two of us have a hard stop at 5:45, so we slow down at 5:45. But Jeff, is up to you again. Thank you so much. If you have questions, please send it to me, peter@wca.org. Thank you, and see you soon in one of our next events. I say bye-bye.
Yeah. Great. Thanks, Peter. So yes, so I think we can continue our discussion. As Peter said, I think the speakers are very gracious to to stay a bit longer. So for the audience that's still here, we can continue our discussion. And later, we will actually look through all the questions people have. We will compile them, and then we will send it to the speakers to their own expertise to answer. And then we will post this in our WCA website for the answer. So I guess well, thank you. And then Dinash, thank you for your answer and about the challenges you see in a different perspective. So Tom, I think the same question to you, but related to your industry. What do you see the what preventing from the adoption?
Yeah, well, Dinesh really, summarizes it very well. It's the total cost of ownership. You have to really look at the value that wireless charging provides, right? So initially, companies like BMW had launched a limited number of wireless charging units, but the standard wasn't set. So until the standard gets set, you would worry that once you start shipping wireless charging units, and then car manufacturers say, well, these cars become obsolete with the standard system once it comes out. So people have been kind of waiting until interoperability can be guaranteed, and now it's almost there. Right? SAE is done. GB standard, the second half is coming out this year. So once that's done, then there's no worry about launching a wireless power system. So that was one of the things that was an issue with the EV. And then with other systems, I think the primary concern was the cost, because like robotics, conductive charging is prevalent already. So in factory automation or logistics supply, those robots can go back and, just like Roomba, right, go back and charge conductively inside of a factory. And so basically, once the cost of the wireless charging system comes down enough that combination of the maintenance and any hazards with conductive charging causing fire hazards and so on becomes more than cost of deploying wireless charging, then it switches over. And I think it's that we're starting to see a number of additional companies that are deploying wireless charging systems for robotics to show that the cost is coming down enough that perhaps we'll see the cutoff. The other one is like outside usage. If the robots are being used outside, then you have to have an all-weather condition system, which typically is hard to do with conductive systems. So wireless charging system value increases there. In automotive applications, initial adoption for consumer-owned cars will be very high-end cars, because wireless charging system still costs some money. And then eventually, once the EV adoption increases and autonomous drive MaaS, right, mobility as a service, starts to get deployed, which is also hinging on EV costs coming down and autonomous driving system being enabled, and regulatory approval, and so on. Once that goes, then autonomous charging becomes a necessity. And at that point, it's a comparison between conductive charging and wireless charging. And like I said again, with the lowering cost of the wireless charging system, outside use cases would really make sense for wireless charging. So these are the conditions that we're waiting to see how, when we're ready to launch wireless charging systems, we will be there with a cost competitive, safe wireless charging systems to meet the market needs.
I see. Well, thank you. I think it is always true when you have a standard and then you want to ask everybody to agree to play the same book. It is usually takes longer than you expect.
Right. It took several years longer than we originally anticipated.
So do you think in terms of a technology wise, it is ready to deploy in terms of wireless charging, not just other standard EV? Do you
right.
think...
Wireless charging, robotic charging is already available from manufacturers like TDK, Daihen, and Delta Electronics, and large scale, high power wireless charging systems available from a couple of manufacturers. There's one company working on EV chips, and then for cars, we have a number of tier ones working on the system development right now. We're starting this. We're expecting to see announcements coming later this year, early next year from a few car manufacturers. So the time is right, I think, for the rolling out the features.
Yeah, no, this is-
Autonomous shuttles, we're still cooking. We're still cooking with
Yeah.
a few companies.
It's getting there. It's getting there. No, this is great. Great to hear. I think this industry on the EV is blooming and growing very fast, actually. So a lot of industries are surrounded around this EV industry.
Right,
So,
and we expect to see the battery cost come down enough where, I think the cost of battery will be like half in the next 3 years or so.
mhm.
And at that point, electric vehicle cost of purchase as well as cost of ownership would go down below the gas engine ones, which really changes the world, right? And at that point, I think need for wireless charging, need for autonomous charging really increases.
That's
So
right.
it'll be a perfect storm. We can see a perfect storm in a few years.
Yeah. Well, thank you. Thank you for the answer. For Simon, same question to you. In your space, how did you see the challenge on the adoption?
Yeah, I think specific to our markets, our company was founded, like I said, out of the frustration that users were experiencing, but also deployers were experiencing. And so it was essential for us to solve the technical hurdles first before introducing it to the market, which is why we went to market last year with products that were well received. So that the technical hurdles of efficiency and thermal management and foreign object detection and being able to scale and cost issues and things like that just had to be solved first, regulatory issues. I think that there's two things that both Dinesh and Tom said that I really want to echo is it did take a very long time for the standard to be developed for the undercar charging, and that has really enabled that industry to take off. And similarly, we don't want to see existing standards organizations get disintegrated with the proliferation of proprietary standards. And I'll be blunt, it can be frustrating to be part of a standards organization because there's a lot of competing ideas, but it does benefit everyone not to break that system. And so, we charge everything. So we have contingency plans for everything, but really would like to see the standards bodies hold on strong. And the other thing I would say is just, I think from our customers, our collective customers' experience, Dinesh showed dozens and dozens of different markets for wireless charging. Literally everything can be wireless charged, and there is a value proposition for it, whether it's power tools or industrial IoT or mobile phones. And I would challenge all of us, I think we do quite a good job, but I challenge anyone that plays in this market to know what you're good at and know what you're not good at, and don't confuse the customers. So if your efficiency is X, don't say it's part of X and then leave out, half of the equation and have the customer figure it out after they've committed to a POC. The pie is big enough for everybody. We can all have a big slice if we really choose what we're good at, know what we're bad at, and focus, and don't confuse our customers. But other than that, impediments to getting into vehicles, we're looking at similar cycles to Tom. They're just standard business cycles for automotive and standard business cycles for other industries. And thankfully, the growth of those looks really pretty fabulous.
Yeah, that is true. Well, thank you for your response on this. I do think the wireless charging and the power are at its infancy, and the things that wireless power can enable are, basically limitless. And right now, it is how the industry as a whole, gather together and to agree on certain things. While we definitely the whole goal is to serve the end user, right? The goal is to provide the flexibility, provide all the user experience. So I think that basically all of us in the industry is to do that, to serve our customers, right? So I think it is very true, and it is very difficult. It is not a simple thing to do, especially it requires collective talents, right? Collective body of different things to all come together. So it is quite complex. So well,
Jeff, Jeff, before you move on to Ashish, let me add up to what Simon mentioned, a very important trend that came to my mind. As we see this wireless power technology getting adopted into wider applications and wider sectors, one trend which I'm seeing is, which is what I'm not a bit comfortable, is that we are seeing, obviously we have a standard, we have the base product ready, but we are starting to see more and more proprietary solutions coming in the market. It's good, it's getting wireless power into many devices, but I think in the long run, it's very, very important that we have the standard which keeps on moving with the times as well. So I'm not saying that we should not have, non-consumer devices which are running on proprietary wireless power solutions. It could run it. In fact, it can run much, much better than that. But I think we also have to think about the ecosystem. We also have to think about the regulatory approvals, because if every player is coming with the proprietary solutions, we require different approvals. Regulatory bodies is very, very, getting tied up with all those things. So if the standard is there, it's become easier for everybody to really get these devices into wireless charging technology in a much, much wider phase there. So I think it's very, very important that we keep that in mind and work towards getting a standard out, working on a product which is more standard based rather than proprietary solutions. I know it's a difficult thing, but still I guess people understand that, this is very important.
Right, that is true. Yeah, thank you for your comment. So, well, Ashish, I think the same question to you. I think in your industry, it's actually different than the EV and in the mobile phone. How do you see the challenge on your side of how to scale your industry in the IoT space?
Yeah, I mean, I think the big thing is really desperation. So we need to find a core desperation area to be able to solve. That's something that you can look into history as well. I think for the audience, ask yourselves, how do we get wireless communication technology in our hands? What was the desperation point that actually created that? If anyone wants to put it in the chat, let me know. I'd love to hear what your desperation points for wireless communication were that actually brought it to the world, that is in your hand right now as a mobile phone. So yeah, desperation is one aspect. The other part is, in the end of the day, what we're dealing with is a feature. Not a product. Right? So you just have to understand that. Yeah. So we are a feature, like right now, we're developing an IoT system. But we're just a small feature of that IoT system, making it a bit simpler, easier, lower cost, allowing for the ROI. And the other day, we're just a feature. Right. And we have to accept those two things. We're not a product where you can just sell that. We have to create turnkey solutions with that feature, provide the architecture around it, understand exactly how it's developed. We're still a very early stage adoption, to be honest. Yeah. Then obviously, once we kind of like establish that perspective of what are the core requirement points to have be successful, then yeah, for sure, standards would be fantastic, to latch onto and start going after. But yeah, I would say the big thing is those two things which I mentioned. Yeah. Yeah. No. Thank you for that. I think the IoT space is quite interesting, right? So, actually, in our previous WCA wireless power section, we talk about whether the growth of IoT is limited by the battery growth, right? And I think you are actually beautifully addressing that problem. And then the idea is how we grow the number of connected devices in the world, and that will enable more and more needs for the wireless power or wireless charging in that matter, right? So, yeah. So thank you for the response.
Jeff, yes. Jeff, can I add something here as well? Because Ashish mentioned about the IoT sensors, and he's working on that sector in a very good shape here. Again, because my current report, I'm doing a report on IoT sense, wireless power and IoT sensor, which is publishing in a couple of weeks' time. I think one important thing which I'm seeing there is why there is a slow adoption, why there's a slow movement, despite having some companies working on this technology. I think one of the things which I'm sure Ashish will agree is that we do not have a standard. So imagine Ashish going to his wider customer base and saying, I have a technology, I have a solutions, let's start to adopt that. An example, he mentioned about Schneider Electric. So imagine if Schneider Electric has a solution which is more in the standard form. So it makes things for Ashish much easier to go and adopt wireless power in a wider form, rather than saying, okay, this is my client, this is my customer, this is the factory, 2,000, 3,000, 5,000 sensors is what I have to deploy wireless power into. Rather than saying, okay, all these sensors out in the market are compatible with wireless charging standard, a distance charging standard. Now let's go and do it in a large scale. This is a big challenge in the industrial sector as compared to the consumer sector, because in consumer sector, if you add wireless power, you directly get into millions and millions of devices. But in IoT, or I would say in the industrial sector or medical sector or even say retail sector, you really have to go customize. And it will take a lot of time for a wider industry to get into, I would say, cut the cords in those sectors as well. So I guess that's also why I'm saying the standard is very, very important, so that it goes where we get into the fast adoption.
Great. Well, thank you, Dinash. So I think the time is about up. And as I say, I will compile all the questions that we won't be able to address today. And I want to thank all the speakers and thank you for your time. And I know, Dinash, you are like midnight, right? Or something. But you don't seem like a very tiring. So maybe you can stay for another while. But yes, I think I don't want to take everybody's time. And this is a great, and I would like to end the section here. So if, so I think we will have the next event and then we can talk again. So I will thank everyone. And
Thank
I
you,
would also
Jeff.
like to thank I would also like to thank WC and all the members here, panels here. Thank you very much for the opportunity.
Thank you very much for listening. Thank you very much for
Thank
inviting
you.
us.
Thank you.
all right.
Thanks.
Thank you
guys.
for
Have a
being
nice
on the
night.
panel.
Okay, bye.
Good night, Dinesh, and good morning, Ashish. Thank you. Bye-bye.
Thank you. Bye.
Bye bye.